All right, so this is problem number 11 from worksheet, 11.5? All right, so we got this Atwood with friction and a massive pulley. All right, so in the figure at the right, we've got two blocks, and the problem tells us that both blocks have a mass. So we'll call this M1. Well, why don't we just call them M? Yeah, we'll call them M1 and M2. Sorry. So here's what we know. We know that M1 is equal to M2 is a stupid 6.2 kilograms. All right, we've got a massless string over a pulley. So the mass, the radius of the pulley is 0.024 meters. Sorry, converted the 2.4 centimeters into meters there. And a rotational inertia, so it just flat out gave us the rotational inertia, and it's 7.4 times 10 to the negative fourth kilogram meters squared. The string doesn't slip on the pulley, so that means that the linear values for the box and the outer edge of the pulley are all going to be the same. When the system is released from rest, the pulley turns through, so the change in angular position for the pulley is 0.13 radians, and it does that in a time of 91 milliseconds, so that's 0.091 seconds. And it's going from rest, so the initial angular velocity of the pulley is 0. Okay? So that's our given information. Okay? So what I'm going to do is so question A wants to know what's the magnitude of the pulley's angular acceleration. So that's just kinematics. All right? I think, let's see, so we got displacement, time, and initial angular velocity. So for part A, I'm looking at this equation. Right? All of our forces are constant, therefore our acceleration and torque are all going to be constant. All right, so we can just solve this thing, right? Because we know our delta theta, we know our time, initial angular velocity 0. So do a little bit of algebra and solve this thing. And your alpha ends up being, let's see, so 0.13 times 2 divided by 0.091 squared. And it gives you 31. Let's just call it 31.4 radians per second squared. Okay, so that's part A. All right, so then part B says to find the magnitude of the block's acceleration. Well, the idea is the whole system is accelerating at the same rate. Okay, so that means the boxes, the rope, and the outer edge of the pulley, which is at the crux of this. So for part B, to find the acceleration, the idea is we know the angular acceleration of the pulley. That's going to correspond to the linear acceleration of the outer edge. So our acceleration, we ought to just be able to use a jumper to do that, right? We know that the outer edge of the pulley, well, the whole pulley, is accelerating angularly at 31.4 radians per second squared. And it has a radius of 0.024. And so we get an acceleration of 0.7535 meters per second squared. All right, so that's the acceleration of our whole system, which is very, very useful. All right, so let's do this. I'm going to write these down. So we found our alpha, and that turned out to be 31.4 radians per second squared. We found our acceleration of the outer edge of the pulley, which again corresponds to the rope and therefore the blocks. So our acceleration is 0.754 meters per second squared. All right. So now what we need to do is find the tension in the two strings and then find the coefficient of friction between the sliding block and the table. All right. So what I want to do is I want to make a free body diagram for sort of each component of the system. Okay. So for M1, let's think about what our free body diagram looks like. And I'm doing these in no particular order. I'm just going to go through and do all of them. So for M1, we've got the force of tension 1 and the force of friction. So let's see. So I know net force equals net force. That means my mass, 6.2 kilograms, times my acceleration of 0.754 has got to equal the force of tension 1 minus my force of friction. All right, so that is one equation. All right. Okay, let's do M2. All right, for M2, M2 is going to give us something. All right, here's what we know for M2. We know that we've got our block. Gravity is pulling it down with a force of 6.2 G, right? And then you've got the force of tension 2. So I feel like it's going to, yeah, all right. So let's see. So let's do this. So net force equals net force. So that means the mass of this thing is still 6.2. The acceleration is going to be this way, right? So 0.754 meters per second squared equals our force of gravity, which is 6.2 times 9.8 minus the force of tension. So in this system, I've made down be positive, right? Because both my acceleration and my gravity are downwards. Okay? All right, so that's another equation. And fortunately, this one I can actually solve, right? I can find that force of tension. Oh, this is force of tension 2. Okay? All right, so I guess we might as well solve that, right? Well, so I'll come back and solve it in a second. So before we solve anything, let's do this. The last thing we got to look at is the pulley, right? So our pulley is going to look like this. Here's the pulley, and it's got two tensions on it. It's got the force of tension 1 pulling it this way, and the force of tension 2 pulling it this way. So now I'm going to do net torque equals net torque. So my net torque is I alpha. So my I, we know it was given to us in the problem up here. So, well, here, so it's this. So it's I alpha equals the torque from tension 1 plus the torque from tension 2. Watch your signs. My acceleration is going to be this way, right? So I'm going to make this positive, okay? So let's see. So our I was given to us at 7.4 times 10 to the negative fourth. Our alpha we found before, it's 31.4 radians per second squared. That's got to equal the force of tension 1 times that radius, right? So the radius is going to be just the radius of the wheel, which was 2.4 centimeters, so 0.024 meters, plus, I got to exit out of this zoomy mode here. View, zoom, let's do about 75%. We'll scroll down, extend the page. Okay, sorry. Okay, so here we go. So I alpha equals the force of tension 1 times its radius plus the force of tension 2 times its radius. And one of those torques is going to be negative, right? So it looks to me, based on my sign convention, the torque from tension 2 is going to be, the negative one, right? So you got to put a negative there. All right? So what I've got now is 3 equations and 3 unknowns, right? So I guess let me simplify this one. So this equation, once you simplify it, you're going to get this red one. So 7.4 times 10 to the negative fourth times my angular acceleration, which is about 31.4. It's actually a scotch less. So I'm using my calculator here. I used a stored number. So that gives you 0.02323 equals, well, I can just distribute this, right? This becomes the force of tension 2 minus the force of tension 1 times 0.024, right? So now I've got 3 equations and 3 unknowns. Here's equation number 3. And then here's equations 1 and 2 in red and green. Okay? So from here, basically what we're going to do is solve, right? So I believe, let's see, let's do this. Dual page. All right, so this blue equation I can solve. for the force of tension 2, right? So let's see, 6.2 times 0.74, 6.2 times, again, I'm cheating and using my calculator, saved numbers. So you get 4.672 equals 6.2 times 9.8 is 60.67 minus the force of tension 2. So solve this and you find that the force of tension 2 is 56.1. So that's actually question D, right? All right, now that we know that, let's see, which equation can we plug that into now? Well, this equation doesn't even have tension 2 in it. So let's go down to this red equation and plug in tension 2. If I plug in my tension 2, I can solve for the force of tension 1. So using this red equation gives me 0.0232 equals force of tension 2 minus the force of tension 1 times 0.024. So solve that. So let's see. So we want to do this guy divided by 0.024. So I'm looking at 0.968 equals 56.1 minus the force of tension 1. So minus that, and it gives you 55.12. Force of tension 1 is 55.12 newtons. I guess technically it's in a negative direction according to the pulley, but all right. And so now finally, now we can go back up and do the green one. Okay, so the green one is going to give us, well, let's see, 6.2 times that. So 6.2 times, let's find that number from before so that I don't lose anything to rounding. Why I'm worrying about this all of a sudden, I don't know. All right, so that gives you 4.67, that's this thing, equals the force of tension 1 minus the force of friction. So solve this, and your force of friction ends up being, oh, I guess I should do 50.4 newtons. All right? So that is how you do that. Systems of equations.